of significant digits. So when you're doing mathematical calculations, it's always a good idea to keep one or more digits then is significant to reduce rounding errors. But in the end, after you finish calculating your problem, you should only end up with the proper number of significant figures. So let's say that the problem that you worked out is either addition or subtraction. In this case, we're going to do addition. The result is significant. So 89.332 plus 1.1 equals 90.432. This should be rounded to get 90.4. The reason that we only rounded it to 90.4 is because in the number 1.1, the tens place is the last significant place. After you multiply or divide, the number of significant figures in the result is determined by the original number with the smallest number of significant figures. For example, let's say you multiply these two numbers, and 12.61092 is your answer. You should then round it off to 12.6. The reason for this is because there are only 3 significant figures in the number 2.80. So be sure to bear in mind all of these rules that I've gone over with you, because even though you've calculated the correct answer, but you've written it in the wrong form, then more than likely you're going to get the answer wrong on the test. Alright guys, let's move on to scientific notation. Scientific notation is pretty helpful when it comes to physics. So whenever we're measuring physical phenomena in the real world, we encounter numbers of large magnitude. So, of course, performing calculations with these huge numbers is really impractical. That's why we have a shorthand method, which is our scientific notation. In actuality, every number can be written in scientific notation as a product of two numbers, such as a greater decimal than or equal to 1 and less than 10, or a power of 10 written as an exponent. So I'll just go over with you real quick on how to write numbers in scientific form. Step number 1. Write the number as a decimal, if it isn't one already. Let's say we want to change 360 million to scientific notation. The first thing that we're going to do is write it as a decimal, like so. Next we're going to move the decimal just enough places to change this old number to a new number, a number that's between 1 and 10. Move the decimal point to the right or the left so that only one non-zero digit comes before the decimal point. Make sure to drop any leading or trailing zeros as necessary. So let's go back to 360 million. Only the 3 should come before the decimal point because we're using a number that's between 1 and 10. So the next step is to move the decimal point 8 places to the left. Get rid of all the trailing zeros, and your result is 3.6. Multiply the new number by 10, raised to the number of places you moved the decimal point earlier. So, since we moved the decimal point 8 places, we have to multiply the new number by 10 to the 8th power, hence getting 3.6 times 10 to the 8th. Number 4. If you move the decimal point to the right in step 2, put a minus sign on the exponent. But we moved it to the left, so we don't have to take any action here. Therefore, 360 million in scientific notation is simply 3.6 times 10 to the 8th. Changing a decimal to scientific notation is basically the same thing. For example, let's say that we want to change this number to scientific notation. Let's go back to our steps. Number 1. Write the number as a decimal.
That's easy, because it's a decimal.
Exactly. So number 2. In order for us to change our original number to a new number between 1 and 10, move the decimal point 5 places to the right and drop the leading zeros. So our result is 6.113. Number 3. Because we moved the decimal point 5 places, multiply your new number by 10 to the 5th power. And, like I said earlier, because we move the decimal point to the right, that means that we should put a minus sign on the exponent. Our original number, in scientific notation, is simply 6.113 times 10 to the negative 5th power.
Hey guys, good morning!
I'm Roxanne.
And I'm Marcel. And this day, I and Roxanne decided to have a morning exercise here at Kamay ni Jesus, Lokban, Quezon.
This chapter, our topic is all about
Describing motion, kinematics in one dimension. But Roxanne, how can we define motion first?
motion.
Motion is like this.
What is the difference between distance and displacement?
Well, it's like this. If we assume that north is towards the top of the paper, south towards the bottom, west towards the left, then east is going to be towards the right. Let's suppose that we start on point X and walk or run the distance to point Y. Distance is going to be 100 meters. So in this case, the distance that you walked was 100 meters. And displacement was 100 meters east. The difference between the distance and displacement is that distance is the length of the path that you travel. And displacement is the distance and direction between the starting point and ending point. Note that the displacement has the distance plus direction.
This must mean distance is a scalar quantity.
Yes, Ara. It is only measured and has a quantity but doesn't have a direction.
Okay, so in the case of displacement, it should be a vector quantity.
It has a direction unlike distance.
So in this particular case, the distance that we traveled from X to Y was,
100 meters.
yet displacement was,
100 meters east.
No need to fear, super speed is here!
And I am Velocity Guy.
Hey, man, you're ripping my powers off.
No, I'm not. Speed and velocity are completely different. Speed and velocity are two different things.
No, they're not.
They are. They're different. Just watch this.